This is a pseudo design that illustrates the challenge of challenge number 8, and that's to pick up a ball or a similar object with two rollers rather than two wheels. As I alluded to in challenge number 7, there's many, many different ways of doing these intake mechanisms. As a matter of fact, many times the thing that differentiates a good robot from a great robot, okay, is the fact that a good robot kind of intakes okay, or a great robot intakes very, very quickly. And matter of fact, with a great intake mechanism, they're commonly used the notion, the saying that if we touch it, we own it, which means anytime the robot gets that intake mechanism near the ball or the game element in general, that robot gets it. Okay, and it can now have it and it could store. It could use it for scoring. So this is again one of these kind of pseudo designs. It's probably a good place to base your design. Matter of fact, make something like this and then start developing all the different things you need to keep it together. Now this one has the two rollers. So here's a front roller and here's a back roller. The ball is just like the ball we had before, and this gray plate down here is the ground. So the one thing that I had to add on this, I like to keep the pseudo designs really, really simple, but what I had to add here is an arm because these rollers have to be on an arm to make this thing work. And so I needed to show you that. And this arm is attached to the ground. It would be attached to your robot back here, okay, and with a pivot. And the pivot is right here. So we have these are the mechanisms. So with the arm, we can do this. We can go up and down, and both rollers are connected to the arm. Now notice if we zoom in a little bit, this roller is connected to the arm up near the top of the arm, and this roller is connected to the arm down near the bottom of the arm. So we're thinking that maybe that the rollers are not at the same heights, okay, when we do this. So the design of this is a little bit more complicated. Again, the robot's back in here. Okay, so if we wanted our robot to be that chair, we would just, oh, I can't push this whole thing up. The chair is basically your robot over in this orientation. Okay, so let's take a look at this and see how it works. This wheel is rotating in a counterclockwise direction. Okay, or the rollers rotating counterclockwise direction. And I can't see what this roller's doing because of this arm. So I want to show you something about the arm. I'm going to right click the arm and I get a little pop-up here. And one of the pop-ups is saying make this part with a little eyeball thing in there, and it's make it translucent. Do you see the translucent there? If I move over it in it, it's really nice that these little pop-ups will tell you what the symbols mean. So if I make it translucent, then I have this situation. So it allows me now to not worry about the bar getting in the way of the demonstration. So I have the front roller going in a counterclockwise direction, the back roller going in a clockwise direction. So the rollers behave similarly to the way the wheels would behave. So if we move it up here and we move the ball here, the ball, when it contacts, let me move the issue with move it here. So the ball's going to contact. Let's see, look at the contact. This roller. So when the ball contacts the roller is going to try to put a force on it that's going to roll the ball in this direction. It's trying to push it in this direction. Okay. Now, in order for it to do that, though, this is on a little on that arm. So actually the ball pushes that roller up. As the ball comes in, the roller pushes the ball even further up. So we find that as the roller's moving the ball into the pickup mechanism, the ball is raising the pickup mechanism, as we see here. So we move it a little bit more, and it raises it up like this. And so we continue. Now, why is the ball moving in here? Because the roller is on top of it and it's pushing the ball in. It's rolling the ball into this mechanism. And so it's going to continue to roll it. Okay. Now, once it gets over here, notice what happens. This arm starts going down because the ball is supporting that front roller, which is pushing the arms up. So, or the arm up. So what happens is as the ball continues to move, this roller continues to stay in contact with the ball. And that is so very, very important because we learned with the wheels is if we lose contact with the ball, then the ball's got to do what it wants to do. It could stop, it could roll the other direction or whatever, but we're in constant contact with this. We continue to move. I was going to move the wheel or the roller, but I'm going to move the wheel instead. You say, oh, but now it's not in contact. Ah, contraire. This arm dropped down and it's still in contact. We move over here and it's still in contact. Okay, well, I moved a little bit too far. Okay, so we're moving here, and I moved a little bit too far, excuse me. Bring it up. And so, but notice what's happening. The ball is getting closer to the back wheel. So the ball is going to move a little bit further here, and now it's just about ready to hit the back wheel. When it hits the back wheel, okay, what's going to happen? Okay, the ball's in contact with both the front wheel and the back wheel. The back wheel is pushing this side of the ball up. The front wheel is pushing this side of the ball up. So the ball is squeezed between here, and the ball will rise. So what happens after so the ball's going about this far. At this far, it's pretty straightforward. The two wheels are squeezing the ball between them and pushing it up almost vertically, just a little bit to the right. Now what happens is it depends how fast these wheels are moving. If the wheels are moving fast enough, the ball will actually come out and it will flip into the robot. Okay, and here. Now, sometimes you don't want it to do that, so you'll get the ball up like this, and just about at this point, the ball will hit a little stop up here. So we put a little wall up here, and then the ball will just stay there. Okay, up in here. Now, one of the things we talked about the wheels. Let me bring the ball out and over here. Is we've talked about how closely the robot has to center itself in order to pick up a ball. Now, in this case, if we look at this system, these rollers are just arbitrarily sent to 300 millimeters, which is probably good for an FTC robot, the front end of an FTC robot. This ball can be, the ball just disappeared, excuse me. Ah, the ball went over here. I have problems with that pesky ball sometimes. Let me push the ball through the floor. You can only do this on a simulation. There we go. Okay, that makes more sense. So what I was trying to show is that if the ball is, let me get it back in. If the ball is over here, it will hit this roller, and pop into the robot. If the ball's in the middle, it'll do the same. If the ball's over on this side, it will do the same. So what happens here is that the robot will pick up that ball not only when it touches the ball, when it travels into the ball, but the ball can be way off-centered on the robot and still enter the robot with this. The wheels, the ball can be somewhat off-centered, but not nearly as much as this. The two wheels we talked about last time, since they were 2-inch wheels and a 2-inch ball, the ball could probably be off-centered by, let's say, a ball radius, plus or minus a ball radius. In this case, the ball can be off-centered by something like 250, or if these are 300 millimeter long. So it would be about 150 millimeters, subtracting the radius of the ball. So it'd be something like 100, plus or minus 100 millimeters. This means that the robot can pick up the ball very, very quickly and does not have to be very accurately positioned. A big boon for the drivers. So anyhow, this is the two roller mechanisms, and we looked at it from here. Of course, this is going to be attached to the robot, and in your case, you're not going to have a robot, so you'll have to kind of figure out how you're going to attach this thing and build these things up. A couple of things here that I think are important. Obviously, the speed of the two wheel, or the speed of the two rollers. Again, the rollers have a tendency to be moving relatively quickly compared, let's say, the wheels on the drive wheels on a robot. So that's why we use that ultraplanetary motor with the ultraplanetary gearbox, so we can get different speeds on this thing. The other thing, obviously, is the radius of these rollers. It makes somewhat of a difference. The other thing is the covering of the rollers. We want these rollers to be compliant. And it's hard to get rollers as compliant as you can get wheels. We can actually make these rollers by stringing a whole bunch of wheels together, and you'll see many teams do that. The other thing is that we can make a cylinder, a non-compliant cylinder, and then cover it with a compliant material that we would make these wheels. The other thing you need to think about is where this pivot point is, okay? How far back from the wheels it is, so this kind of horizontal distance, and also how far up from the ground. It turns out if this pivot point is too high, the system will not work at all. So you need to look at the geometries of this to make it work. And then the final piece, of course, is how far the back wheel or the back roller is from the height of the upper roller, and that also has a lot to do with this angle of the arm, and then also the distance between these, because if the distance between the centers of the two rollers is too small, then obviously the ball gets stuck between them. If it's too large, you don't get enough force to pop that ball out of the rollers. So with this, I think we're done with it. This design is actually quite similar to the design, I believe, of this particular unit is much easier than the design of the wheels. And why? Because if you look at the rotation is in a vertical plane on these, which means that the motor can be mounted on its side, which makes it much easier to get these things together. But remember also that these two rollers are rolling in different directions. Okay, and so you just can't use belts to do this. There needs to be a gear or something, or a gear or a belt that would go through and turn these things around. So anyhow, with that, have fun with it.